Now we are seeing a problem from the topic friction from the subject engineering mechanics. Let us see the problem. Find the effort required to move a load of 10 kilonewtons up the plane of 30 degrees angle. Coefficient of friction is mu and tan inverse mu is equals to 15 degrees. The effort is applied parallel to the plane. So here a body is moved with a force or effort of P on an inclined surface which is making an angle of 30 degrees with the horizontal. So we have to find out this effort value when this effort is applied parallel to this inclined surface. And here the weight of the body is 10 kilonewtons given, and this R is the normal reaction by this surface, and F is the frictional force. We know when the body is trying to move upward, this frictional force will act downwards. So anyway, we'll analyze this in the next steps. So here we have to find out the effort parallel which is applied parallel to the inclined surface. So that effort value we have to find out here. Means here we have to find out this P. So let us see this given information. Weight of the body is given. Let us take as W is 10 kilonewtons, and inclination of the plane with the horizontal is given 30 degrees. Let us take it as alpha, and tan inverse mu is given 15 degrees. So mu will become tan 15, and this mu is nothing but coefficient of friction, and that value is 0.268. And here let P is the effort which is applied parallel to the inclined surface which is required to move the body up the plane, and F is the frictional force acting between the body and this inclined surface. So the given body is equilibrium under the action of forces. So if you see this figure, so first of all the body is moving up the plane because of the force P. So and R is the normal reaction which is applied by the surface on the body, and we know weight of the body will act vertically downwards. So if you observe this diagram, just P is applied here and the weight of the body is vertically acting downwards, and R is the normal reaction applied by this inclined surface on the body, and when the body is trying to move upward, frictional force will act downwards. So here W we can resolve into two perpendicular components. One is perpendicular to the plane and one is along or parallel to this inclined surface or plane. So like this we can resolve the forces. So this W, weight of the body vertically acting downwards to the center of gravity, and so if you resolve this, so one component is perpendicular to this inclined surface, so that we can write as W cos alpha, that is nothing but 30 degrees. So if it is 30 degrees, so here also this is 30 degrees, and this component of this W is nothing but W cos alpha, that is nothing but W cos 30 degrees, and this component, the component parallel to this inclined surface is nothing but sine component, that is W sine alpha, or that is W sine 30 degrees. And so this R is balanced by this W cos 30, and if P is acting up the plane, and this W sine is 30 is going down the plane. Why? Because this W is a vertical force, weight of the body acting downward direction. Means if you resolve, so it is resolved into two components, and so one component is will go like this and other components will go like this, depending because the W will act downwards. So here, and F is the frictional force which is acting opposite to the direction of force applied or motion of the body. So if you consider the equilibrium of the body under the action of these forces, and also when you resolve the forces normal or perpendicular to the plane, so we know, or I told that already, R is the reaction force applied by the surface on the body, and that is balanced by this W cos 30 degrees. So we can write like this: R's normal reaction is equals to W cos 30. W is the weight of the body given 10 kilonewtons, and cos 30, and if you simplify that, you are getting normal reaction R as 8.66 kilonewtons. And next, resolving the forces along or parallel to the plane. So I told, or in the given question it is given that P is the effort applied parallel to the plane, and this is going up the plane, and this should be balanced by this frictional force and also W sine 30. So we can write here P is equals to W sine 30 plus F. So W sine 30 plus F should be balanced by, so this should be balanced by this P. So that we have written here P is equals to W sine 30 plus F. So W 10 kilonewtons sine 30, and F, we know F is equals to mu into R. Why? Because mu is equals to F by R. So we can write F is equals to mu into R. Frictional force is equals to coefficient of friction into normal reaction. So from the basic principles we know this formula. So when you write F is equals to mu R and substitute mu value is 0.268, the given is a given data. Find out from this given data we can write mu value 0.268 and R value we got in the previous step 8.66, and if you substitute these values and you simplify, we are getting P is, that is effort, is 7.32 kilonewtons. So this is the effort required to move the body up the plane. So this is the way to solve this kind of questions. So for more videos, please subscribe and activate bell symbol, and also please share it with your friends. Thanks for watching.